Good morning, students. Today I will be starting wave propagation. The first topic is general wave equations. There are certain assumptions made. One by one, I will list assumptions. Assumptions made. First one, the medium is linear. The medium is linear. What do you mean by the medium is linear? Medium is linear means vector E and vector H, vector E and vector D are parallel to each other. Vector H and vector B are parallel to each other. This is the implication of the medium being linear. The medium is linear. Vector E and vector D are parallel to each other and vector H and vector B are parallel to each other. Second one, the medium is homogeneous. The medium is homogeneous. That means the properties of the medium is identical at all points inside the medium. The medium is isotropic. First is medium is linear, second is medium is homogeneous, third is medium is isotropic. Medium being linear is explained by saying vector E and vector D are parallel to each other and vector H and vector B are parallel to each other. Medium is homogeneous means the properties of the medium are identical at all points inside the medium. The medium is homogeneous. Third assumption is the medium is isotropic. Medium is isotropic means mu and epsilon do not change with respect to direction. Mu and epsilon do not change with respect to direction. If the medium is linear, homogeneous and isotropic, then it is called uniform. Medium is called uniform. Uniform means it is linear, homogeneous as well as isotropic. So in wave propagation, these are three basic assumptions made. These three basic assumptions you have to write it in the examination also. Correct now. The medium is homogeneous. The medium is linear, homogeneous, isotropic. Fourth assumption, there are no charges nor currents inside the medium. There are no charges nor currents inside the medium. That means medium is charge free. Fifth assumption, the medium obeys Ohm's law. Ohm's law means vector J is equal to sigma into vector E. So these are the 5 assumptions that you have to make for deriving wave equations. Now I will start wave equations one by one. Wave equation for vector E. The Maxwell's equation derived from Faraday Lenz's law is del cross vector E is equal to minus vector dou B by dou T. This implies del cross vector E is equal to minus mu into vector dou H by dou T because vector B is equal to mu into vector H. This I call equation number 1. The Maxwell's equation derived from Ampere's circuital law is del cross H is equal to vector J plus vector dou D by dou T. Medium obeys Ohm's law. Therefore, what is vector J? Sigma into vector E. What is vector D? Epsilon into vector E. So this is nothing but sigma into vector E plus epsilon into vector dou E by dou T. Equation 2. This is the Maxwell's equation derived from Faraday-Lenz's law. I have made the substitution vector B is equal to mu into vector H. This is the Maxwell's equation derived from Ampere's circuital law, which is del cross H is equal to vector J plus vector dou D by dou T. Vector J is equal to sigma into vector E, Ohm's law in point form. Vector D is equal to epsilon into vector E. Now I will substitute equation 2 in equation 1. Before substituting, what I will do is taking curl means what? Del cross. Taking curl on both sides. Taking curl on both sides of equation 1 gives del cross vector E is equal to minus mu into del cross vector dou H by dou T. This I will call equation 3. Since space operator del and time operator dou by dou T are independent of each other, they can be interchanged. Since space operator del and time operator dou by dou T are independent of each other, they can be interchanged. So these two you can interchange. Hence, equation 3 reduces to del cross vector E is equal to minus mu into dou by dou t operating on del cross H. Del cross E is equal to minus mu into dou by dou t operating on del cross H. This is equation number 4. Substituting equation 2 in equation 4 gives del cross vector E is equal to minus mu into dou by dou t. What is del cross H? Sigma into vector E plus epsilon into vector dou E by dou t. This implies del cross vector E is equal to minus mu into sigma vector dou E by dou t minus mu into epsilon vector dou square E by dou t square. This I call equation number 5. From vector calculus, we know that del cross vector A is equal to del of del dot A minus del square vector A. From vector calculus, we know that del cross A is equal to del of del dot A minus del square A. Hence, equation 5 becomes del of del dot vector E minus del square vector E is equal to minus mu into sigma vector dou E by dou t minus mu epsilon dou square vector E by dou t square. This I call equation number 6. The Maxwell's equation, ME is the short form for Maxwell's equation, derived from Gauss's law of electrostatics is divergence of D is equal to rho D. Since medium is charge free, because of the assumption charge free, since medium is charge free, we get divergence of D is equal to 0. This implies divergence of vector D is what? Epsilon into vector E is equal to 0. This implies epsilon into divergence of vector E is equal to 0. Since epsilon cannot be 0, it implies divergence of E is equal to 0. This is equation number 7. Substituting equation 7 in equation 6 gives divergence of E is equal to 0 gives what? Minus del square minus del square vector E is equal to minus mu sigma vector dou E by dou T minus mu epsilon dou square vector E by dou T square. Remove minus sign throughout, so you get this equation. Equation 8 is the wave equation for vector E in a general medium. General medium. This is how the wave equation for electric field is derived. Next is to generate wave equation for magnetic field. That is our next objective. Wave equation for vector H. The Maxwell's equation derived from Ampere's circuit law is del cross H is equal to vector J plus vector dou D by dou T. What is vector J? Vector J is sigma into vector E plus what is vector D? Epsilon into vector E. So you get epsilon into vector dou E by dou T. Taking curl on both sides of the above equation gives del cross vector H equals sigma times del cross vector E plus epsilon times del cross vector dou E by dou T. Del and dou by dou T are independent of each other, they can be interchanged. What is del cross H? Del cross H is del of del dot vector H minus del square vector H is equal to sigma into del cross vector E plus epsilon into dou by dou T operating on del cross E. This I will call equation number 9. Since del cross E is equal to minus dou B by dou T is equal to minus mu into vector dou H by dou T, equation 9 becomes del of del dot vector H minus del square vector H is equal to minus mu into sigma vector dou H by dou T minus mu into epsilon dou square by dou T square operating on vector H, equation 10. The Maxwell's equation derived from Gauss's law for magnetic fields is divergence of B is equal to 0. This implies del dot, what is vector B? Mu into vector H equal to 0. This implies mu into del dot vector H is equal to 0. Since mu cannot be 0, it implies divergence of H is equal to 0. This is equation 11. Making use of equation 11 in equation 10, what happens? The first term will become 0. Making use of equation 11 in equation 10 gives minus del square vector h is equal to minus mu into sigma vector dou h by dou t minus mu into epsilon dou square vector h by dou t square. Minus sign I can remove throughout, so it becomes like this. This is the wave equation for vector h. This is equation 12. Equation 12 is known as wave equation for vector h in a general medium. In general, the wave equation for an electromagnetic wave, EM wave, in a general medium. EM, electromagnetic wave means both electric and magnetic fields are present. A general medium is given by del square vector E or vector. This is general form. It means del square vector E and del square vector H. Our combined equation 8 and 12 is equal to mu into sigma dou by dou t operating on vector E and vector H plus mu epsilon dou square by dou t square operating on vector E and vector H. This is the first order term because of dou by dou t. Since first order term is present, it implies the amplitudes of vector E and vector H decay as the wave progresses. First order term means dou by dou t term. For this reason, a conducting medium means sigma not equal to 0 is also called a lossy medium. Since the first order term is present in the wave equation, it implies the amplitudes of vector E and vector H decay as the wave progresses. For this reason, a conducting medium is also called a lossy medium. Thank you. Next topic, propagation of uniform plane wave in a perfect dielectric medium. First, let me tell you what is a plane wave, then what is a uniform plane wave. See, a plane wave A plane wave is one for which vector E and vector H lie on a plane, and all such planes are parallel to each other, and are perpendicular to the direction of propagation, The phase of vector E and vector H on such planes is a constant. What I have written? A plane wave is one for which vector E and vector H lie on a plane, and all such planes are parallel to each other and are perpendicular to the direction of propagation. The phase of vector E and vector H on such planes is a constant. Now let me take the Cartesian coordinate system. This is x-axis, this is y-axis, this is z-axis. Let us say this is YZ plane. Direction of propagation is x. So this YZ plane is perpendicular to the x-axis. This is the direction of electric field. Electric field is given by the magnitude of electric field is Ey. It is parallel to y-axis. The magnetic field is parallel to z-axis. It is Hz. So Ey and Hz lie on a plane. Next, as time progresses, this plane propagates. This is the next plane. Here also you see Ey and Hz lie on the YZ plane. The phase of Ey and Hz is constant on such planes. That means the expression for Ey could be Em into cos omega t minus beta x. Omega t minus beta x is called the phase. Em is called the amplitude. As t increases, x increases. Therefore, omega t minus beta x remains constant. So this plane may be at t equal to 0.1 seconds. I am just assuming. This plane could be at t equal to 0.2 seconds. As t increases, you will see the planes, these parallel planes propagating. I have taken as an example, Ey is equal to Em into cos omega t minus beta x. Omega t minus beta x is called phase. As t increases, x increases. Therefore, omega t minus beta x remains constant. If the amplitude Em is also a constant, then the plane wave is called a uniform plane wave. If the amplitudes of vector E and vector H are also constant on such planes, then the plane wave is called uniform plane wave. Right? A plane wave is called transverse in nature. Why it is called transverse in nature? Because vector E and vector H are perpendicular to the direction of propagation. If a plane wave is transverse in nature, a uniform plane wave is also transverse in nature. I am going to write a uniform plane wave. UPW is the short form for uniform plane wave, or a plane PW is the short form for plane wave. A plane wave, I will write full form. A plane wave is transverse. A plane wave is transverse in nature. That is vector E and vector H are perpendicular. Perpendicular means orthogonal. Orthogonal to the direction of propagation, or orthogonal to the direction of propagation. Then note. So first I have told what is a uniform plane wave. Please note that for a uniform plane wave, vector EY, see vector E and vector H are pure functions of x only. Why x only? Because the wave is propagating in x direction. I have assumed the electric field to be in y direction because EY is perpendicular to x axis. Hz is also perpendicular to x axis. So EY and Hz are at right angles in direction of propagation. I assume the electric field to be in y direction, magnetic field to be in z direction. In fact, EY and Hz are orthogonal to each other and the direction of propagation. Please note that for a uniform plane wave propagating in x direction, Ex will be 0. Means no component of vector E in the direction of propagation. Similarly, Hx equal to 0. That means there is no component of vector H in the direction of propagation. So vector E and vector H should always have components orthogonal to the direction of propagation. Second thing is, the phase of Ey and Hz remains constant. That means if you take, I have taken an example of Ey as Em into cos omega t minus beta x, omega t minus beta x remains constant on such planes. Please note that. For a wave propagating in x direction, vector E, what is vector E? Ey into Ay cap. What is vector H? Hz into Az cap. They are pure functions of x only. Correct? Pure functions of x only. If the wave is propagating in y direction, it will be a pure function of y only. These are the certain important implications you must know about a uniform plane wave. So, what is a plane wave I have told? Then I have told what do you mean by a uniform plane wave. A uniform plane wave is nothing but a plane wave with amplitude Em equal to constant. Instead of Em, for example, instead of Em, if you have Em into e to the power minus alpha x as the amplitude. Instead of Em here, if you have Em into e to the power minus alpha x as the amplitude, then as x increases, the amplitude Em into e to the power minus alpha x also decreases. Then it is called a plane wave. It is not a uniform plane wave. So I have told you now what do you mean by a plane wave and what do you mean by a uniform plane wave. So what I write, you don't write in the examination. I just written those examples in order to make this concept clear. Next I will tell you what do you mean by perfect dielectric medium. This is note number 1. Note number 2. Perfect dielectric medium means conductivity sigma equal to 0. Perfect dielectric medium means conductivity sigma equal to 0. So now I will write the wave equation for vector E in a general medium for vector E in a general medium is given by general medium or a conducting medium or a lossy medium. They all mean the same. General medium means you can say conducting medium or lossy medium, all mean the same. The wave equation for vector E in a general medium is given by del square vector E is equal to mu into sigma vector dou E by dou T plus mu into epsilon vector dou square E by dou T square. This is the wave equation. This is the wave equation for electric field in general medium. For a perfect dielectric medium, for a perfect dielectric medium, or a lossless medium, we have conductivity sigma equal to 0. Hence, del square vector E is equal to mu into epsilon dou square vector E by dou T square. This is equation 1. Equation 1 is known as wave equation for electric field in a perfect dielectric medium. Let expanding del square vector E gives dou square vector E by dou x square plus dou square vector E by dou y square plus dou square vector E by dou z square is equal to mu into epsilon dou square vector E by dou T square. This is equation number 2. I have expanded del square operator. Let us assume that the uniform plane wave, UPW means uniform plane wave, is propagating in the x direction, then vector E and vector H are pure functions of x only. Since they are pure functions of x only, dou square vector E by dou y square and dou square vector E by dou z square equal to 0. Hence equation 2 reduces to dou square vector E by dou x square is equal to mu epsilon dou square vector E by dou T square. These two variations are 0 because vector E is a pure function of x only. Next I am going to say let vector E be equal to Ey into Ay cap and vector H be equal to Hz into Az cap. The wave is propagating in the x direction. The electric field is assumed to be in y direction. The magnetic field is assumed to be in z direction. That means vector E and vector H are orthogonal to the direction of propagation. Please note that. Then dou square by dou x square. What is vector E? Vector E is Ey into Ay cap equals mu into epsilon dou square by dou T square operating on Ey into Ay cap. The vector differential equation now becomes a scalar differential equation. This implies dou square Ey by dou x square is equal to mu epsilon dou square Ey by dou T square. Now to solve this differential equation, it has to be reduced in terms of one variable only. There are two variables. One is space variable x, the other one is time variable t. So I will now reduce this equation. into a partial differential equation having only x variation. That means I am going to remove time variation. This is right. This is, I think, equation number. This is equation number 3, I suppose. Okay. Let Ey be equal to E naught into e to the power j omega t. Then dou square Ey by dou t square is equal to mu epsilon into E naught j square omega square e to the power j omega t equals minus mu into epsilon omega square into Ey. So dou square Ey by dou t square is what? Minus mu epsilon omega square into Ey. This is equation 4. Making use of equation 4 in equation 3 gives dou square Ey by dou x square is equal to minus mu epsilon omega square into Ey. Now we look at this equation number 5. There is only space variation, there is no time variation. Therefore, by assuming Ey equal to E naught into e to the power j omega t, from equation 3, I have removed the time variation dou square Ey by dou t square. Let dou square by dou x square be equivalent to d square operator. Then equation 5 reduces to d square Ey is equal to minus mu epsilon omega square Ey. This implies d square plus mu epsilon omega square into Ey equal to 0. The characteristic equation is replace d by m square plus mu epsilon omega square equal to 0. So this implies m is equal to square root plus minus square root of minus mu epsilon omega square equals plus minus j omega into root of mu epsilon is equal to plus minus j beta. Where beta equal to omega into root of mu epsilon is defined as phase shift constant and has the unit radians per meter. If beta is 0, the wave cannot propagate. Beta cannot be 0. So beta is what? Omega into root of mu epsilon. Now, what is the solution of partial differential equation 5? We are solving for Ey in terms of x. This is a second order partial differential equation. Therefore, there will be two constants associated with the solution. So I am going to write now. Hence, the solution of the partial differential equation 5 is, you are solving for Ey in terms of x. So it is Ey is equal to Em plus. This plus has got no mathematical sanctity. That superscript plus means What does it means? It represents a wave traveling in the positive x direction. I'll talk about that later. E to the power m1 into x plus em minus means the amplitude of the wave traveling in the negative x direction. This minus sign also doesn't have mathematical sanctity. The superscripts plus and minus why I have taken, I'll explain in the final solution. E to the power m2 into x. What is m1? There are two roots. What is m1? Minus j beta. What is m2? Plus j beta. So this becomes what? em plus into a to the power minus j beta x plus em minus into e to the power plus j beta x. This is first term, this is second term. This is equation number 6. Equation 6 is called phasor form of solution. It has got only space variation, there is no time variation. If you want to get time variation introduced into the phasor form of equation, multiply the phasor solution by e to the power j omega t and then take the real part. So, what I mean to say that is, equation 6 contains only space variation. And is known as phasor form of solution. To get time domain solution, multiply phasor solution by e to the power j omega t, phasor solution by e to the power j omega t, and then take the real part. That is vector, so that is Ey as a function of x comma t is equal to real part of Ey into e to the power j omega t. That means multiply phasor solution by e power j omega t and then take the real part. So if you multiply Ey by e to the power j omega t, what you get? Real part of Em plus into e to the power j omega t minus beta x plus Em minus e to the power minus j omega t plus beta x. What is real part of e to the power j theta? E to the power j theta means cos theta plus j sin theta. What is real part? Cos theta. Real part is what? Cos theta. So this is nothing but Em plus cos omega t minus beta x plus Em minus cos omega t plus beta x. So this is the first term on the right side. This is the second term on the right side. This is equation number 7. First term represents a wave traveling in the positive x direction and is called forward traveling wave. The phase of this wave, namely omega t minus beta x, remains constant because as t increases, x also increases. Therefore, forward traveling wave is a plane wave. Also, the amplitude of this plane wave, namely Em plus, is a constant. Therefore, forward traveling wave is a uniform plane wave. Second term. Second term represents a wave traveling in the negative x direction. This is also a plane wave because as t increases, x decreases. Therefore, the phase omega t plus beta x remains constant. The amplitude of this plane wave, namely Em minus, is also a constant. Therefore, the wave traveling in the negative x direction, also called backward traveling wave, is also a uniform plane wave. This I am going to write now. The first term on the right hand side of equation 7 is called forward traveling wave. And travels in the positive x direction. Since it travels in the positive x direction, I put Em plus. That is the significance of the superscript plus. The phase omega t minus beta x of this wave remains constant because as t increases, x also increases. Also, the amplitude of this wave, what is the amplitude? Em plus is also a constant. Hence, first term on the RHS of equation 7 represents a uniform plane wave traveling in the positive x direction. What I've written? The first term on the right hand side of equation 7 is called forward traveling wave and travels in the positive x direction. The phase omega t minus beta x of this wave remains constant because as t increases, x also increases. Also, the amplitude Em plus is also a constant. Hence, first term on the right hand side of equation 7 represents a uniform plane wave traveling in the positive x direction. Represents a uniform plane wave traveling in the negative x direction. The phase omega t plus beta x remains constant because as t increases, x decreases. Since the wave is traveling in negative x direction, I have put here Em minus. Thank you.